All right, the Atmos clock is pretty much disassembled. I wanted to work on the spring mechanism and the winding mechanism here. So I took the bellows off, and if you look closely on the back of the bellows is etched in, scratched in 572. So it looks like either when this was manufactured or when the bellows was replaced. Usually the people who service the bellows put a date on it. So May of 72 is when this bellows was put in, and we'll watch this um, and see if it's winding itself or not. And but let me take you through. I also took off the front of the clock, which is obviously the thing that turns the mechanism into minutes and counts the hours, so the gearing. But it also has this follower that works off of the pendulum. When a pendulum swings left and it moves a little, and then it basically kicks it left and kicks it right. And what we're going to see here in a minute is the spring that's going to give this some kinetic energy, so that every time it counts off a minute, it gives the pendulum a little bit of kick. So it's an important piece and it has to be aligned correctly. But it all comes off and starts back here with the bellows mounted in place and pushing and pulling on this spring. And we'll demonstrate that in a minute. Right now it's all unwound. And if I push and pull on here, you'll see that it drives this gear. And when this plate is in place, obviously it picks up its energy from this gear, and this doesn't spin freely like it is right now. Let me turn this around here a little minute, because it's interesting how you take something that's going like this and turn it into winding a spring that's inside this barrel. And so what they do is the chain comes in and does a 90-degree angle, if you can see that right there. But there's a pulley that's laying flat that turns it into this thing, and then you see the spring here that's wrapped around the winding piece, and that goes onto this gear. And the reason for this gear is there's little fingers back here that keeps it from unwinding. So every little in and out, in and out, in and out moves this, and incrementally moves this up and keeps the spring wound. So there's always banked up energy here to drive the clock, when the pendulum is swinging. And it'll do that whether or not the pendulum is free to move. If you've locked the pendulum into place for shipping, for example, the pressure's still going to go. It's still going to do this winding. It's still going to wind up to the point where it can't wind it anymore. It's too tight. But this is where the energy store is, if you will. And I was having problems with seeing if this metal gear was working free, and how much, whether the spring, I didn't take this part apart. I'm trying to avoid that. You got to take the plate off, and there's 4 screws that hold the gear to the barrel. Whether it was all glued together and not, expanding and contracting, how much energy can it store? And the way you test that is basically like I have it here. Basically, you pump this and you watch it wind, and you make sure that you get at least, I've seen 6 and 7 and 8. I'm getting almost 10 winds. So that's maybe the way I'm not pushing it all the way tight. But the problem is if I push it and I don't restrict this, now that I have the face off, nothing's restricting it from moving. So if I do this, it just spins and releases the energy. But let me do a trick. Well, it's not a trick. I'm going to stick a screwdriver in here just to jam this, and you'll see what happens here in a minute. Let me do it this way. Yeah. So now, that gear is going to try to spin, but the screwdriver is going to stop it. And then I'll be able to get the pumps. I'll be able to do this one-handed. But watch what happens. You'll see the chain move, and you'll see the ratchet. When I let go, when I release it, see how it ratchets, and it's winding the spring now. And my screwdriver just moved because it all of a sudden it started picking up some tension. But this happens all day long. As the temperature changes, and it probably doesn't go this far, but it constantly, slowly winds that barrel. It has the mainspring in it. So whenever the pendulum is swinging and it needs little kicks, it picks it up off of there. So what I'm going to do now is test it. There is some videos that show how many compresses you should get to make sure that it's winding fully. But I'm getting quite a bit. you wind it up to the point where it doesn't want to wind anymore, or it can't because the pressure off of the spring is can't be overcome. So it eventually, once it's loaded, if you will, yeah, see, it's already not coming back very far. So it's still winding it a little bit. And I'm going to work on that to make sure that, we're getting as much spring compression as we can. But eventually it's going to stop like that and say, I can't go any farther. Now, when I take that screwdriver out, it's going to go wild. So I'm going to do that carefully and let it unwind slowly rather than, freewheel. But anyway, that's the mechanics. And I've heard it explained that the only difference between really an Atmos clock and the rest of it is the way instead of a key on, winding the spring directly, or a battery or something like that, it's the way that it winds itself. So the rest of this is pretty much a standard clock, a standard mechanism for hours and minutes and things. But it's this bellows going in and out. That's the unique trick that the Swiss came up with for these Atmos clocks. Anyway, that's a video, that's an update, and pretty happy. I was worried that this wasn't really free and working, winding correctly. So I'm going to work on it a little bit more, make sure that I can get, not nice clean compressions and expansions, and make sure that spring is working and expanding and contracting well. And then I'm waiting on a suspension spring, which ties it, all together for the, that's what was broken. I mean, it was broken in two pieces. So, and that, actually comes up here. I don't know if you can see the tail of the old one is still hanging out the top, but you get a 9-inch spring, and that's what they call it, a spring, but it's really just a thread of 0.05 millimeter, probably tungsten steel, and it twists and untwists, and like I said, gets a kick of energy every minute when it flips left and right through that mechanism. That's it. Thanks for watching.